Last one, the combustion strategy. Anyone want to take a guess as to what type of reaction this is? How about combustion? Yeah, it says it right in the title there. Noted by a hydrocarbon plus oxygen. And here's something for you. You always get carbon dioxide and water. So every time you see a combustion reaction, you will always get carbon dioxide and water as your products. So if you're going to predict the products, this one's easy. It's always the same. Okay?
Is this one double?
Huh? Combustion.
Okay.
Okay. Now, this is one of the only ones that I would strongly urge you to follow my directions step by step, and you will get the right answer. If you don't follow these directions step by step, you're going to be there forever trying to go back and forth and balance, okay? So, with that in mind, first step. You don't really even have to tally up on either side. Balance the carbons first. How many carbons on the reactant side? 4. How do I get 4 carbons on the product side? Put a 4 here. So far, so good. Second. How many hydrogens on the reactant side? 10. How many on the product side? Or let's say this way, how do I get 10 on the product side? 5. So far, four carbons, 10 hydrogens. Third, count up the oxygens on the product side. We have 8 here, plus 5. 13. That means I need 13 oxygens.
Wait, how did you get
How'd I get what?
8?
4 times 2,
Oh,
8. And 5 times 1 is 5. That gives me 13. So what number can I put in here on the reactant side to get me 13 oxygens? You'd like to put 6.5, right? 6.5. But you're not allowed to put 6.5, are you?
Whole numbers.
I know. Now we've seen this before, haven't we? The 0.5 thing. But we got to keep the ratios all the same, but we can't have a 0.5. Multiply by 2. But I got to multiply everything by 2. That means this has to be multiplied by 2. So I have to put what? There's a 1 there already, so that becomes 2. 6.5 times 2 is 13, just like I wanted. 4 times 2. I changed that pretty slick, huh? And 5 has to change to 10. Shall we tally up? How many carbons?
8.
8. Hydrogen?
20.
20. Oxygen?
26.
26. Carbons on this side? 8. On the product side?
16.
Hydrogen?
Wait, sorry.
10 times
Oh.
2, 20. And oxygens,
26.
right? I have 8 times 2 is 16. Plus 10, 26. So, carbons first, hydrogen second on the reactant side, oxygens third on the product side, and then you can kind of follow your nose from there. Question? Which where? This one? Well, I wanted to put 6.5, and that would have balanced it. But I'm not allowed to use 0.5. So I needed to double it. But if I double that, I got to double everything, because it all has to be proportional one side to the other. What's that? 6.5 times 2? 6.5 times 2 is 13. That's how we got 6.5 in the first place. We wanted to cut 13 in half, put a number here, times 2 would give us 13. So we chose 6.5.